Alright, hi Scholar. Today we're going to do Scholars. Today we're doing skill 15, solving logarithm equation. So there are many different cases, different possibilities of the logarithm equation, and I'm hoping to address this. So first case is if the logarithm equation has only one logarithm expression. So it can look something like, well, what I meant to say is that if the logarithm is in one side of the equation. So I have log base 2, 3, there's something extra is equal to a number. So something that looks like that. In other words, if you see the problem, like this one, if I draw a line here, do you see logarithm is in one side? Yeah. Logarithm in only one side of the equal sign. Logarithm is on one side of the equal sign. So that's what I meant by that for that first case. So what do you do? Number one, condense it to one logarithm equation. So how do you condense it? Well, we learned all the rules on the previous skill of how to condense a logarithm, so that should be enough. Number two, what do? We're gonna exponentiate both sides using the base of the log. That's one way you can think about it, or if you want to think about the other way, you can just say convert exponential form. Convert to the exponential form. And last but not least, solve for x. Solve for x. So that probably doesn't really mean anything for you unless I do the problem. So let's look at it. Look at this example on the right side. I'm gonna look at it. If I do a line here, I have log on one side of the equal sign, right? Only on the left side. So step number one, I need to condense to one logarithm equation. So let's go ahead and condense it. I see the 3 over here, so I'm going to move that as a exponent of 3 using the property we learned last class to get log base 6 of 8x minus log base 6 of 5 cubed is equal to 0. Notice both of them have log base 6, so I can condense as a one single logarithm. Log base 6 of 8x minus means the negative exponent, 5 to the third power. Or in other words, you divide it on the argument, equal to 0. So I'm done with the step number one. So this is step number one. What is step number two? Exponentiate both sides using the base of the log, or convert to the exponential form. So this is where your preference, right? When you get to this part, some of you are like, Mrs. Major, can I just do 6 to the 0 power equal to this weird thing, the argument? Yes, you can do that. So 6 to the, let me use the orange color, 6 to the base, exponent 0 is equal to 8x over 5 cubed. So you can do that way. Or you can exponentiate using the base of the logarithm. What do I mean by that? I need you to move this as an exponent. So what's my base? 6. I raised to 6 raised to log base 6 of 8x over 5 cubed is equal to 6 to the 0 power, which using the property I can cancel this out. 8x over, by the way, 5 cubed is 125 is equal to 6 to the 0 power is 1. Either way, I don't care. Okay, so those are two ways you can go about it. But you're going to get to the same this part, and then step number 3, solve for x. Multiply 125 to both sides. 8x is equal to 125. X is equal to 125 over 8, which I can probably put in my calculator together as a decimal. So that's how you do it. Now, there's one very important thing about the logarithm equation. That is, we always have to check it. What do I mean by that? Once you get this x value, I need you to go back to the original equation and try to plug it in. And if you ever get negative base or negative argument, it's invalid. So check by, plug in into the original equation. Make sure base and argument are both positive. If it ever gives you negative argument or negative base, that's not the answer. So I got this, right? 125 over 8, which is approximately 15 point something something. So if I plug into original, 8 times 15 is positive, and that's the only place for the x, so this is okay. So step number 4, check. It is good. It's all positive. Good? Alright, if you have a logarithm on both sides of equal sign, which I did not really give you any example, but it can look something like this. Log base, give me 1 second. Log of x plus 3 plus log of x is equal to log of 10. Step number 1 will be, same thing. I have 1 log on each side. So I multiply these. Log of x times x plus 3 is equal to log of 10. And then what do? You exponentiate. So my base is 10 here that you don't see. So I'm going to raise to the 10 raised to log of x times x plus 3 is equal to 10 raised to log of 10. And then solve it. Boop. X plus 3 is equal to boop, 10. X is equal to 7. And last but not least, check. So I take 7, plug it in. That's a positive. That's a positive. So I am good. Okay, so that's the case when you have log on both sides. Now, what are you going to do if you can't do any of them? You're going to graph and find x value of the intersection. I mean, that should come in to your brain by now, right? Because we did it with the exponential equation. When you can't solve it algebraically, we graph, find the intersection. Good? Alright, so those are just the work. Now let's look at some examples together. Which one do I want to do? Let's look at this one together. Always number 1 is a good. I have log on the left side of the equal sign, so let's go ahead and condense it. That 4 goes as an exponent of 3. So log base 2 of 5x plus log base 2 of 3 to the 4th power is equal to 5. Both with the base 2, multiply. So log base 2 of 5x times 3 to the 4th power is 81. Is equal to 5. Which is log base 2 of, what is it? 405x is equal to 5. So I'm done with step number 1. Step number 2, exponentiate both sides using the space of the log or convert to the exponential form. How would you guys like to do? I personally just like to convert to the exponential form. So 2 to the 5th power is equal to 405x. 32 is 405x. X is 32 over 405. Is that divisible by 3 or 2 or anything like that? 405 divided by 2. Duh, I should know that doesn't work. I don't know it's divisible by anything. So I'm just going to leave it like that, which, by the way, if I put it in a decimal, I get approximately 0.790. 0.790. Alright, make sure we check our solution. How do you do it? Take that, plug it into the x. 5 times 0.790 is still going to be positive. So that gives me positive argument. I am good. So always don't forget to check it. Okay? Now I'm going to pause this video. What I recommend you doing it is try to do the next 2 problems and we'll go over it together. Okay? So pause it and try. Alright, so this problem over here, I put 3 as exponent, divide it, raise to the exponent, convert to the exponential form, multiply 27 to both sides, divided by 8, 121.5. When I plug that in, I get positive argument, so I'm good. Next problem, there's no coefficient in front of the logarithm, so I don't have to put as exponent. I just simply went ahead and divided, since both of them have a base 5. Convert to the exponential form. I got the following. Let's just review it together. I'm probably going to cross multiply. So 25 times x plus 1 is equal to 4x squared minus 4. 25x plus 25 is equal to 4x squared minus 4. That's a quadratic equation. How do you solve quadratic equation? Set it equal to 0 and factor. Yeah. So how should I do it? Multiply to be negative 116, add up to be negative 25. What is it? Oh, 4 and 29. Put negative in front of 29. So 4x squared minus 29x plus 4x minus 29 is equal to 0. This is just the regular factoring, right? So x, 4x minus 29 plus 1, 4x minus 29, 4x minus 29, x plus 1 is equal to 0. I get x equal to 29 over 4 and negative 1. Now, let's make sure we check it. 29 over 4 is about 6 point something, no, 8, 7 point something. So when I plug it in, 7 point something times 4 is a big number, minus 4 is positive. 7 point minus plus 1 is positive, so I'm good. What about negative 1? Guys, be careful here. When I take negative 1, I plug it in here. Negative 1 squared is 1 times 4 is 4. 4 minus 4 is 0. 0. Can I have 0 on my argument? No. So negative 1 is not the solution. So that is why over here checking is super important. Okay, you good? All right, now I have 3 more problems for you. Go ahead and do those, and we'll review it together. All right, so I just did these 2 problems. It might take a while for you to do it because the factoring numbers are a little complicated. So if you were struggling with it, pause it and then see this work, kind of just get an idea of what is happening. But really, nothing was hard. I was just factoring it. I actually didn't finish the problem on purpose because of the last step, checking. So let's go ahead and check it. For x value, this problem, I got 3.25 and negative 1.5. Let's go ahead and check it. Where do I plug that 3.25 in? To the original equation right here. So make sure you get the positive argument and positive base. So when I plug 3.25, everything is positive. 3.25 times the 2 is 6.5 minus 6 is still going to be positive. So that means this one is good. What about negative 1.5? You know what? I'm not even going to plug it in the first one, but I'm going to plug in the second one. Because remember, what we were checking is it going to make it negative or not? 2 times 1.5. Negative 1.5 is negative something. Minus 6 is definitely going to be negative. So that one is out of the look. So you only have one solution. So that's why we need to always double check it. Okay? Now let's look at this one. Let's go ahead and check it. 4, plug it in. That's a positive. It's going to be positive because everything is plus. Negative 2, I don't know. Let's see. Negative 2 plus 4 is positive. Negative 2 squared is 4 times 3, 12. Minus 8 is still going to be positive. So this one has both solutions. Okay? Alright, the last one, I have log on one side of the equal sign, particularly natural log. So let's get rid of that negative 3 by adding 3 to both sides. So I get natural log of 2x minus 1 is equal to 2. Now I'm going to change to the exponential form. Guys, what is the base of the natural log? E, right? So we should not forget about it. So 2x is equal to e squared plus 1. X is equal to e squared plus 1 divided by 2, which I can plug it in my calculator. Oops. There's the e button right here. So second e squared plus 1. And then I'm going to divide by 2. I get 4.195 approximately. Now let's go ahead and check it, plug it in. 2 times that is going to be minus 1 is going to be positive, so I am good. Okay, so I actually cover all the types of the problem that you will see on your Delta Math. I mean, between these 6 problems, it covers all the types. Okay, so if you're getting stuck on a Delta Math problem, these are a good place to look at. All right, well, good luck.